Hello, One-Away class. Welcome here to section 7.6. Mr. McHugh hanging with you, and we are going to tackle variation here in this section for page 1. So these problems are dealing with concepts you're already familiar with, so let me just help you out here. So if you look at my notes here, it says y varies directly as x increases or decreases via multiplication. Okay, so here's the idea. Everybody, most of us are out there working and we get paid an hourly rate. Let's assume you're not getting a pay raise here next week or next week. And so I'll make it real simple. If you get paid $10 per hour and you wanted to figure out if I worked 5 hours in a day, what would that output be? You think of y equals k times x. Think of a linear equation almost. X is your input, how many hours you work, but you know your rate is $10 per hour, so the more hours you work, the more output, which is your money that you make, right? So of course you'd say you would make $50. However, if you turn around the next day, you turn around and you know you're still getting paid $10 per hour, but you work 8 hours, you know that you earn 10 times 8 or $80. So the bigger the input, the bigger the output. The smaller the input, the smaller the output. That's called direct variation. Okay. One way to think about this is, I thought this was an example. I think I got this out of the book here. Think about your gas pedal. You're driving along. The farther down you push on the gas pedal, what happens to your car? The faster you go. So the farther you push on the gas, the faster you go. Okay, so that's a direct variation. Sometimes that's called a direct proportion. If you let up on the gas pedal, what's going to happen to the speed of your car? You'll slow down. Okay, so you'll get that. Now, objective 2 asks you, that hourly rate we were talking about, or that constant. K is a constant. It is a variable chosen by mathematicians to represent a number. Okay, it's not a variable, it's a number. And so my example here, if I told you you worked 5 hours and you got $50 output, what would you do? You would take let me squeeze this in, $50 divided by 5 hours, and you'd say, well, of course you're making $10 per hour. I'm just trying to get the concepts going on here for you, okay? So the bottom line, when you do these problems, there's a two-step process. There's a two-step cycle. The first cycle is to find the constant, the k, and then the second one is, with that known given information, you find the k. The second cycle is to find the question with knowing what the constant is. Okay, so I kind of showed it up here in the hourly rate here. So let's go ahead and work with example 1. And so I like to tease in class. You find out your teenage son or daughter is out working for the first time. You're just excited. You've been waiting, and you've been keeping track of the hours because you know he or she's going to get paid, and you know they worked 43 hours that first week. The paycheck comes in, and they go, and let's not worry about taxes. Let's just assume it's under the table. They got $795.50, and you go, oh, that's great, that's great. And you go, oh, how much are you getting paid per hour? And they go, I don't know, I don't remember. Could you help them out? Well, of course, what you could do here is you could say P is your pay equals K, the constant, times H, the hours. Now, common sense is going to prevail here, so watch what we're going to do. If I ask you to figure out what your pay, how many hours you got paid for, your hourly rate, you would take the total amount of your paycheck divided by 43 hours, and $18.50 is what they're getting, their hourly rate. Okay, so then what happens is you go, wow, now that I know that they've made $18.50 an hour, if I asked you in the second part of the problem, how much will they make if they work 10 hours? I'm making this simple. You would turn around and do what? The pay they would get would be $18.50, and of course you're going to multiply that by 10 hours, and you're going to say, hey, they make $185 total pay. Okay, so that's that two-step process. Take a look at example 3 on page 409, and you read that the distance that an object falls from rest varies directly as the square of the time it falls. and when we're going to disregard air resistance. So if a skydiver falls 64 feet in 2 seconds, how far will she fall in 8 seconds? Okay, now when you look at these, you've got to be careful. They say that it's a direct proportion, but it's the distance varies directly to the constant, which you don't know, times the time squared. Don't forget that squared. Okay, so you turn around there and you go, what's the known information? That's the first cycle. Diver falls 64 feet. We do not know the constant, the rate of fall, but we know here's the she went for 2 seconds and we're squaring it, so we've got 2 times 2 is 4. Isolate the k, so 64 divided by 4 is k, and you find out that that is 16. Okay, once you have that constant, you now can answer any question as far as what distance would they fall if they go 8 seconds. Okay, so this is part 2. Given that they're going to fall 8 seconds, how far will they go? 8 seconds is 8 squared is 64. 64 times 16, the constant. Distance is going to be 1,024 seconds. 1,024 feet per second. Man, there's no seconds on that. Sorry, I don't know why I've got that on there. It's just 1,024 feet. Okay. Okay, so that's direct variation, and I see you for page 2. We're going to talk about inverse or indirect variations, and we'll cover those. Okay, Mr. McHugh signing off for now. I'll see you for page 2. Okay, bye.